In this last set of notes, we are going to talk about kites and trapezoids, and we are going to talk about the properties of each of them, plus what conditions we need to see to make sure it is that type of shape. So first off, we're going to talk about a kite. And a kite is a quadrilateral that has two pairs of consecutive congruent sides. You can see that in our picture over here on the right, that these are consecutive congruent sides. So notice that the opposite sides are not congruent to each other. For the four properties of a kite, once we know it is a kite, we know that the diagonals are perpendicular to each other. So the way that they intersect each other will be at 90 degrees. That means that you have four right triangles that are created, and we'll be using those properties themselves to answer some different questions about the angles. Next, you have exactly one pair of opposite angles are congruent to each other. And if you look at where they show up in the picture, if we look at our consecutive congruent sides and the other consecutive congruent sides, is the angles that connect the two of those together. So separate out your kite into two equal pieces. One of the diagonals is going to bisect the pair of non-congruent angles. So that would be over here, that those angles are bisected in half. Now notice they're not congruent to begin with, so all four of those will not be congruent, just the side-by-side angles will be congruent to each other. Lastly, exactly one diagonal bisects the other. So this diagonal that connects the congruent angles together is the one that is cut into two equal pieces. We are going to use these properties now to fill in the missing angles in this kite right here. I know it's a kite because I have two sets of consecutive sides are congruent. Then that tells me that these two diagonals intersect at 90 degrees, so angle E will be 90 degrees in all four triangles. The two measures they already gave us was BAE is 28 degrees and BCD is 114 degrees. Now remember that this diagonal down the center is going to be bisecting those opposite angles. So that means this is 28 and the one right next to it is also 28. And if the 114 is the full angle, if I split it in half, that would give me my individual angles, and that would be 57 degrees each. We can use those angles now to find the remaining angles because remember we have a right triangle. So if I take 28 plus 90 plus this angle, that would give me 180 degrees. I want you now to solve for that missing angle. When you add your 28 and 90 together, you get 118 plus this missing angle equals 180. So that means that the missing angle itself is going to be 62 degrees when you subtract that over. And that is the first angle that we are supposed to find is ABE, and that is 62 degrees. Now remember that we have right triangles, so over here 28 plus 90 plus this missing angle would also have to equal 180 degrees. We already basically found that because 28 plus 90 plus 62 gives us 180 degrees, so that angle also is 62 degrees. Now for the same idea for those other two triangles, we need to take 90 plus 57 plus our missing angle to find out what this angle is going to be. When we add 90 and 57 together, that gives us 147 plus our missing angle equals 180. And then when we subtract 180 by 147, we get a 33 degrees. So both of this angle is 33 degrees, and this triangle is congruent to it because we've already got two of the angles together. So that means that this angle D is also 33 degrees. If we look at our different measures that they're asking us to find, so ABC is this full angle. So we need to add these two angles together, 62 plus 33, and that gives us a 95 degrees. So I want you to find angle CBE. CBE is really just the 33 degrees we already found. ADC now. So ADC, we have to add those two together as well. Now remember, these two I have circled are congruent to each other, and otherwise you can take your 62 plus 33 again, and we get a 95 degrees again. We are now moving on to a trapezoid. Is another shape we're going to talk about, and there's two different types of trapezoid. There's just a regular trapezoid, plus there is also an isosceles trapezoid, and we're going to learn the difference with them. First, we're just going to talk about regular trapezoids, so all of our trapezoids will have these properties. A trapezoid is a quadrilateral with exactly one pair of parallel sides, and that would be the bases is what they are called. So base is up above and down below, and the parallel sides are the bases. A trapezoid then has two pairs of base angles. In this picture off to the side, the base angles are angle A and angle D down at the bottom, and the other pair of base angles then would be B and C. The non-parallel sides of the trapezoid, right here, are called the legs. Because we have two sides in our trapezoid that are parallel to each other, then we can use ideas and properties of parallel lines to figure out some different angles. That means that A and B are consecutive angles, and those are supplementary to each other because of these parallel lines. In our trapezoid, for example, 2, we're going to use that same idea. So these two would have to be supplementary, as well as the two on the right. So knowing that those are supplementary angles, I want you to answer this question to figure out, is it A, B, C, or D? The two equations you should have set up for the supplementary angles to find A and B are as follows. Now to solve them, we would subtract the 36 over to the other side, and we would get that A is 144 degrees. If you do the same thing for the 113, B then comes out at 67 degrees, and the only one that has those both correct would be my choice B right here. Now we're going to learn a few things about an isosceles trapezoid, and remember, an isosceles trapezoid has the word isosceles in it, and when we were dealing with triangles, an isosceles triangle had two sides that were congruent to each other. So in a trapezoid, it works the same way. There's two sides that are congruent, and it's the legs that are congruent. So remember, the legs are the ones that are not parallel to each other. So in my picture over here, you can see that the two legs that are congruent are the left and right, and the base is the top and the bottom. So each pair of the base angles, so that'd be A and D and B and C, are going to be congruent to each other. Remember, A and B will be still supplementary, and C and D will still be supplementary just because it is a trapezoid. The diagonals then are going to be congruent to each other, so the whole length of your diagonals are going to be congruent. We're not going to say that they bisect each other because in a trapezoid they don't, just the whole length is congruent to the whole length. To show that your quadrilateral is an isosceles trapezoid, we first have to make sure it's a trapezoid, and with your one set of parallel sides, and then it has one pair of congruent base angles, then the trapezoid is going to be an isosceles trapezoid. Because remember, with a regular trapezoid, we do not need these base angles to be congruent. So if it's a trapezoid to begin with, and the base angles are congruent, then we know the whole trapezoid is isosceles. Next, the second reason is if we again know it's a trapezoid to begin with, and we have congruent diagonals, so like AC is congruent to BD, then we know the trapezoid is going to be isosceles. In example 3, determine the value of y and the length of the diagonal so that the trapezoid ABCD is isosceles. So we want it to be an isosceles trapezoid, and notice that they give us the diagonal lengths themselves are 3y plus 12 and 27 minus 2y. We need the diagonals to be congruent for it to be an isosceles trapezoid, so that means that these two pieces, AC, needs to be equal to BD. So we can set up 3y plus 12 then will equal 27 minus 2y. And I want you to now go through and find what the y value is, plus we need to find the length of the diagonals. When you solve this for y, if you add your 2y over, that gives you a 5y plus 12 equals 27. And in the end, your y value should end up being a 3. So that's the first answer you should have chosen. Then you have to put it back into the two equations for the AC and BD. So if we do the first one, 3 times 3 plus the 12, we get 9 plus 12, which gives us a 21. If you do the same thing for the other diagonal, so 2 times 3 gives us a 6, so 27 minus 6 is also a 21. So remember, both the diagonals should come out as congruent, otherwise it tells you again that your solving part. You did not set up your equation or you did not solve it correctly. We are going to bring back one of the vocab words we've talked about before, and that is a midsegment. We've talked about a midsegment of a triangle, and that's a segment that connects the midpoints of two sides of the triangle together. So when we talk about the midsegment of a trapezoid, it's a segment that connects the midpoints of the legs together. So if you look at our picture over here, that these are the midpoints of the legs. Some of the same properties are going to hold true for a midsegment of a trapezoid versus the triangle, and that means that they're going to be parallel to each of the bases. So before it was just parallel to the bottom part of our triangle because we had a point to the top, but here we have another base, and the bases originally are parallel to each other, so now this is just creating another third line in our trapezoid that's parallel. The length of this is also going to be equal to half of the sum of the bases. So that means I would have to add my bases together and divide it by 2. So think of this as the length of your midsegment is the average of the lengths of the bases. We are going to use now the formula to find what the actual length of our midsegment MN is going to be. So I'm going to label this as an X. Remember, if we add the two bases together, so our 12 plus 28, and we divide that by 2 or multiply by 1/2, that will equal our midsegment. So now I would combine the 12 plus 28 together, and that gives us a 40, times half, or divided by 2, gives us a 20. So the length of MN is 20 inches. Example 5 now is just reviewing some different properties you've seen between kites and trapezoids, and we need to figure out which shape we are talking about. So if we have two distinct pairs of congruent consecutive sides, remember the consecutive sides, that's only for the kite. Letter B has diagonals that are perpendicular. So this one I want you to fill in, is it a kite or is it a trapezoid? And it has to be one of them. The only one that has diagonals that are perpendicular is the kite again. Letter C, which one has at least one pair of parallel sides? Now notice it doesn't have to be opposite parallel sides, but in this case it is, and it is the trapezoid because the kite does not have any parallel sides. Letter D has exactly one pair of opposite angles that are congruent, and that would be your kite. Letter E, it has two pairs of base angles, and the only one even that mentions base angles is the trapezoid. On example 6, we've got really 3 different questions built in here. I want you to give me the most specific name for the quadrilateral that is shown and explain why you know that. So in this first one, we see some different sides that are congruent, even though we're just given the numbers, so let's put our markings on there. And if you notice, we don't have opposite sides that are congruent, we have consecutive sides that are congruent. And the only shape that has consecutive sides that are congruent is going to be our kite. On the second one, I see that we have some different markings in for our diagonals, and if you notice the diagonals are not congruent, this tells us it's not going to be a rectangle, it's not going to be a square because that needs to be true, but we do have one set of opposite sides that are parallel to each other. We do not have that one pair of opposite sides we have that they're parallel, but we do not have that they are congruent. So it's not a parallelogram because we need that to be true for a parallelogram. So the only choices we've got left is the kite or the trapezoid. And a kite, we do not have anything that's parallel, but a trapezoid we do. So it's not isosceles, but it is just a regular trapezoid. Lastly, we have 2 angles that we are given, and we notice they're not congruent to each other, but if we add them together, they equal 180 degrees. That tells us that those angles are supplementary to each other, and those 2 angles are consecutive angles. Because those 2 angles are supplementary to each other, that tells us that the 2 lines that are creating those 2 angles are going to be parallel to each other. So we know that the top and the bottom lines are parallel to each other, which means we only have one set of opposite sides that are parallel. That is not enough information to say it's a parallelogram, so all we've got is that it's a quadrilateral and that one pair of opposite sides are going to be parallel to each other. And again, this will be a trapezoid because of that.